Okay, I found it. I made a simple algebra error or transfer error. I think it was a sign error back a ways. When I combine my terms here, 5 minus 1, that should have been a positive 4, not a minus 6. Okay, that'll change life. Let's see. That should fix some signs, hopefully here. This is still going to be negative 8 thirds. This is now plus 8. This is a negative. Minus. Negative is positive 8 thirds. Minus 8. So let's see, that's minus 16 thirds. And then 8 plus 8 plus 16, that looks better. So how many thirds? 48, 32. Let me double check my algebra there. 16 minus 16 over 3. Oops, 16 over 3. Math to frac, 32 over 3. Looks good. Now, this is an area between two curves, so it's got units squared, right? It's an area. Sorry about that sign error back. But we caught it when we noticed that, or when I noticed that the signs were coming out negative, right? And I know for sure that it should be positive, so I had to have made a mistake somewhere. All right. Let's try another one. Hopefully I won't make a sign error again. Let's try y is equal to 3x cubed minus x. And y is equal to 0. Okay, so let's start off just by finding out where is 3x cubed minus x equal to 0. Well, x cubed minus x equal to 0, can divide my 3 off. Factor out an x there, x squared minus 1 is equal to 0. So I got x equal to 0, that's a difference of 2 squares. X plus 1, x minus 1. So we've got x is equal to 0, x is equal to negative 1, and x is equal to 1. Okay. Let's see, that's a cubic. It's not reversed, so it looks something like that. Right, where this is negative 1, 0, and 1. Okay, so what we're asked to find is this, right, the area between the cubic function and 0 and this. Now, on that interval, from negative 1 to 1, there's a switch in behavior, right? Between negative 1 and 0, the cubic function is greater. And on the interval between 0 and 1, 0 is greater. The cubic function is negative. So we'll have to reverse those. We'll split the interval apart and reverse them. And you'll see that that's where it takes care of the sign and makes it positive, provided I don't make a mistake. Okay. So the first thing I need to do is look at this interval, negative 1 to 0. On that interval, the 3x cubed minus x function is greater than my other function. It's just a minus 0, so no big deal. Okay, so that's on this interval. But now the behaviors switch, so I'm going to have to split that. Now I'm going from 0 to 1, and the behavior is reversed. So this time I need to go 0 minus my function, 3x cubed minus x dx. All right. Well, this one's just going to drop out, so that's no big deal. We might as well just distribute that through. We want negative 1, 0, 3x cubed minus 3x. Okay, plus the integral from 0 to 1. Now, everything's just going to flip, right? It'll be a negative 3x cubed plus 3x dx. Okay, so let's see. Here, these are straight power rules. So 3x to the 4th divided by 4 minus, this would be 3x squared over 2, and barred at 0 and negative 1. That takes care of the first integral. Then plus, let's see, negative 3x to the 4th over 4 plus 3x squared over 2. And this time I need to bar at 1 and 0. All right, these all have x's in, so this first term will just zero out, and I only need to evaluate at negative 1. So we have 3 times negative 1 to the 4th over 4 minus 3 times negative 1 square over 2. All right, so I've just needed to, I need a minus there, because it's 0 minus that. And over here, the second one will zero out since they both have an x in. So it'll just be minus 0, and all I need to do is evaluate at 1. Well, okay, that's minus 3/4, just evaluating at 1, plus 3/2. Okay, let's see what we've got. This is positive, so negative 3/4. This is also positive, since it's a square, but that's a minus, so minus minus, so plus 3/2. And then minus 3/4 plus 3/2. Nice. That looks like 6/2, which is 3, minus, so it's 6/4, so 3/2. That'd be 6/2, 3/2 units squared. Nice. Area between. Ultimately, that's just the integral, right? Or because we're looking at y equals 0, so we're looking at the area under the x-axis. But we're getting twice. Really, we're just getting twice of this. Yeah. You can see that we're getting twice that area right here. These are exactly the same, right? Like that. So we're getting twice exactly the same area there. Okay, good. That one looked all right. And let's do one more. Both of those have been dx, but it works just as well if we're tilted on our side and go dy. It's the same difference. We just change our variables and look for y bounds instead of x bounds. So let's see. Let's say we had y equal to 4 minus y squared and x equal to y minus 2. Well, let's think about what we've got. This is going to add, so I'll have a positive y squared over here and a 4 minus x. I'm just solving, really. We have plus or minus square root of 4 minus x. So that's something like this business, plus or minus. It's a rooty thing that's turned around, right? It's a root that's turned around, and it's still symmetric, and we have both the plus or minus. Okay, and then x equals y minus 2, well, I just add that. Y equals x plus 2, so that looks something like slope of 1 and lift it up a bit, more or less. Yeah. Okay, so we're looking for this in here, the area between those two curves. Now, when we're looking dy, greater is to the right, yeah? Positive x. So on this interval here, the curve, this 4 minus y squared, is greater than our linear function on that entire interval. So we don't need to worry about switching or flipping. And we've got that we're going to take the parabola, subtract the linear function. All right. So I need to know what my bounds are. That means I'm just going to set these guys equal. So 4 minus y squared equal to y minus 2. Let's see. Let's put this over this way. Y squared plus y minus 2. And subtract that over. Y squared plus y minus 6. That looks factorable. Y and y, signs are different. Bigger one is positive. I need product to be 6 and difference to be 1. That's 3 and 2. Bigger one is positive. So 3 and 2. And that looks good. So y is negative 3 and y is 2. All right. So we've gotten the intersections. Negative 3 and 2. So we know what our bounds are. Integral from negative 3 to 2. And again, we've determined on that interval the parabola 4 minus y squared is greater, further to the right, than our linear function, minus y minus 2. This is dy. Now we recognize that these bounds are y bounds, right? And our functions are all in terms of y. Good, now from here, it looks like we're just doing some algebra and we'll have some power rules. So, assuming I don't make a sign error here, let's see, we have integral from negative 3 to 2, negative y squared minus a y, and we have 4 minus a negative 2, so 4 plus 2 gives me a 6 dy. Nice straight power rules. Negative y cubed over 3 minus y squared over 2 plus 6y barred at 2 and negative 3. 2 and negative 3. Okay, now we're just evaluating. Unfortunately, neither of our bounds are 1 or 0, so we don't get anything for free. We actually have to do the evaluations here. We have negative 3 squared, sorry, 2 squared. What am I doing? 2 cubed over 3. I'm evaluating here. Negative 2 cubed over 3 minus 2 squared over 2 plus 6 times 2. Okay, there's evaluating at b. Minus 2 squared over 2 plus 6 times 2. Okay, and minus, now we need to evaluate at negative 3. I have negative 3 cubed over 3 minus negative 3 squared over 2 plus 6 times negative 3. All right, negative 8/3 minus 4/2, well, that's just 2, plus 12. Let's see, this is 3 cubed is 27, it's a negative. So 27 over 3 is 9, and then negative makes that positive, and then a negative makes a negative. I think I've done that right. 27 over 3 is 9. Cubic makes that negative, but the negative is positive, and then negative out here makes it negative again. Okay, here we have 3 squared, that's 9. It's positive since it's a square. So 9 over 2, that's a negative, which is a positive. 9 over 2. And then negative 18, but it's minus, so plus 18. And we're really close now. Let's see, 10 minus 9 is 1, so we have 19. Let's see, 10 minus 9 is 1, it's 19. Plus 9/2 minus 8/3. And at that point, I'm going to cheat and let the calculator do the fraction work. 19 plus 9/2 minus 8/3. Math to frac. 125 over 6 units. Okay, so we can just as well do those dx, and we're looking for the ones that are greater upward, or dy where we're looking for greater to the right. Same diff. Okay, that's area between curves.